Hey guys, welcome to the AI Playground. We're going to be diving into some creative applications today. I'm here with my good old friend Max Sobolev. Max, can you walk us through some of the unique AI applications you have been working on?
Yeah, sure. We've been recently, well, not so recently. It's about like 4 months now. I've been working on um, real-time inference platform. The main idea is to build a framework which can do like real-time inference on real-time streams. So basically, you have a bunch of video, audio streams from various sources, and you can basically do all sorts of cool stuff with them using AI technology. So you can do like text to speech, speech to text. You can have conversational AI with like both. You can also do probably like yes, as you mentioned, some kind of sentiment analysis. So a lot of stuff you can do with that. And so we started putting like proof of concept together, just to understand a little bit how it works and bring our existing knowledge of real-time communication space. See how we can basically blend those. So yeah, at this point we had a little framework. It's pretty much just a proof of concept. Just show me presentation here. Is my screen on now? Oh yeah, now it's this. Yeah, so basically we want to see if we can build open source framework that will help all sorts of real-time users to tap into this technology easily. So yeah, well, what is kind of stated goals for the project? We want to reuse as much as we want the very well deployed and established real-time communication protocols. So SIP, WebRTC, MQTT at some point, etc. We also want to look at some easy niche deployment scenarios. So like TTS, maybe IVR, and that's something I wanted to start with. Actually, like real-time translation, it would be interesting because with those models nowadays, it should be possible for for you to speak to somebody who does not speak the same language and have the machine basically translate between you. So you
Right.
speak in your own language and it goes through some kind of AI, and the other party gets speech in his language. It obviously will have a little bit of delay, but
Right.
as I said, with the latest generation of models, the delay could be pretty reasonable. So I would say should be pretty useful. Yeah, and we want to just to see which models are there and start integrating them. And so that's the kind of concept. Yeah.
Question: What do you, MQTT is interesting. How do you see MQTT applicable to this? For like, is that for like text to speech, speech to text, or absolutely not something else, right?
No, it could be something else. Like MQTT mostly used to collect
Right.
real-time data from all kinds of
Mm-hmm.
sensors and IoT applications. And at some point, we'll have some models who can do useful things with this data. I would say, especially if you're running some kind of your own network. At some point, you will probably hook it up.
Yeah, I
And
thought.
mhm.
Sorry, yeah, I thought at some point, because we do have at TCXE, we do use MQTT for IoT AAA, and one of the things that came to my mind at one point was that you take all this data from the sensors and then you put it into the AI model to summarize it, like use the summarize prompt to basically give you like a summary of all this. What does all this data mean, or maybe suggest, like, recommend some strategies for like power like improvements, like, or water usage improvements, something like that, after it understands the meaning of what this published messages mean, and then start suggesting some ways to have the AI suggest some improvements to cut down your usage costs or whatever. So all right, yeah, that's pretty interesting.
Yeah, but as I said, it's just for the future. Right now, we're mostly focusing on SIP and WebRTC, which are like easy targets and closer to like end user. Anyway, so this is kind of the goals for this INFERNOS project. And this is available on GitHub. You will probably can put some links after.
That's INFERNOS, right?
Yeah.
Okay.
Yeah, and now this is kind of work in progress. This is how we started. This is like 3 months old slide. So this is kind of main concept which we started with, and I will deep little bit into details why it does not really work. So yeah, essentially we this is how it's implemented right now. We have single thread for SIP stack. It runs our CP stack, and that part works just perfectly. And then for each SIP session, we start separate thread and run TTS at this point. So just for now, it's proof of concept. So we try to figure out what works, what does not. And this model does not really work. It works, but on my like 16 gigabytes and pretty decent GPU, I only get like 2 sessions until it overflows. So yeah, it's not very performant, to say the
And
least.
this is like you're doing real-time transcribing, right? Like in real time, as someone is
Yeah,
speaking,
it's
it trying to transcribe.
right now I'm doing the opposite. Right now I'm focusing on trans on uh, synthesis. So right now it does text to speech. So I give it a pro. I can do a little demo. I think it's
Sure.
appropriate at
Yeah,
this
let's do
point.
it. Awesome.
Let me fire it up. And yeah, you will edit it, right? So okay, I don't need to worry
Yeah, it's okay.
about. Let's make a font a little bit bigger. Okay. Okay, latest version. It's not running. Yeah, so as you see, pretty simple to start. So I basically give it IP address of our local PBX in the network, and the password and username, and then once I start it, it should register itself. Okay, I need to conactivate. I think it's speech T5, I think.
So here you're doing a SIP registration to the SIP server, right? Onto the PBX.
Yeah. So as I said, right now it hooks up to SIP. But you can you don't really need to register. If you can just start it and send it SIP traffic directly to it, it will access answer automatically. Let me figure out the kind of name. Media. Oh yeah, so should be this one. Speech T5 probably. Let's see if it works. Yeah, I just upgraded those yesterday, so this is a little bit. Lib mkl sysctl not found. Great. Yeah, and this is actually why I think we have quite a lot of opportunity in this area, because all those frameworks are kind of little bit fragile, I would say.
Yeah.
So you definitely need some kind of at least at this point some kind of custom built OS.
Something that just works.
Yeah, exactly. And then test it and all that. Yeah, that's progress. Yeah, so basically it starts up. What it does right now, it fetches some of the quotes I'm using. Just like Futurama. Okay, looks my PBX is down. Give me a sec, I'll push the power button. Let me just pin it to the address that it used to have. LAN 157. Why it's 174? Huh. Weird. I don't get it. Okay. I had to log into the box and figure out what's on. Yeah, okay. Yeah, it's definitely 174. Looks like some bug. Yeah, okay, so it just, yeah, we should just maybe get back to static.
It's up now, Max.
Yeah. It has a little LCD display, so I can watch progress as it boots. Let's see, it's registered now. Just restart it, I guess, faster. Okay, so we get okay. Now moment of truth. Let me try to put my microphone to there, or maybe just move there. So we dial 1, 2, 3.
Today is Thursday, 4th of January, 2011 morning.
Welcome. Infernos?
It's nothing a lawsuit won't cure.
Hey, I got a busted ass here. I don't see anyone kissing it.
Fine, we'll have rack of nibbler.
Bet you didn't expect that one, Calculon.
Let's
Hey,
see if it
what
goes
hell are
to
you
the
doing
correct
with my
card.
head? You guys realize you live
Seems
in
a
a
little
sewer,
bit.
right? Viva, save me and yourself, I guess, and my banjo and fries.
Yeah, doing okay.
Yeah. John Quincy adding machine.
Maybe just a little bit slow to cache stuff. But now if we hang up and call again, it should probably start much faster.
Today is Thursday.
Yeah, you see it's pretty
January
much instantaneous.
11:05 in the morning. Welcome to Inferno.
I don't know, you hear stuff, right?
Yeah. I can hear the two-way conversation.
I don't see anyone kissing.
No, it's
And I
not
can see
the way.
it's-
It's just a prompt.
Bet you didn't
It
expect
plays
that one,
with
Calculon.
different. So what it does here is it basically, as I said, it downloads some quotes from Wikiquote, also from Futurama, some of them from Matrix, just to make testing a little bit less boring. And then it plays them with in real time, like translates text to speech in real time, so it does not buffer.
So
anything.
we're doing okay. So we're getting the text from the web service, and then it's doing real time text to audio, and
Yeah,
doing...
exactly,
Okay.
exactly. And it unlike many of those commercial providers which offer text to speech, this is done fully in real time, so it does not render the whole prompt. So it basically just sends it to the inference engine, and then it immediately starts to generate an RTP. So basically, between the time it issues this prompt, it decides I need to play this prompt, until it actually starts sending RTP. It's very small delay. It's like less than a second, probably less than half of a second. So basically, you have it does not really generate the whole audio in advance. It does it in very small chunks and immediately sends them out. I had to modify the model to do this, but at the end of the day, it works. And then I added some code to actually track how much load it sees. So from the perspective of application, this number it basically tries to estimate how much time it's waiting for inference. So it basically it's how loaded the torch is at this point. So and as this is like in up to 1, so it's like 40%. So essentially, it sees with just one session, it sees torch already loaded by 40%. Just running one model essentially. But if we look at the GPU here, so let me dial again.
Today is Thursday, 4th of January, 2024, 11:08 in the morning. Welcome to Infernos.
So you see, like GPU itself, it's only loaded like 5%, maybe less.
Yeah, 4 to 5.
Expect that one, Calculon.
Yeah, but now let's see what happens if I try to get Linfon as well. We'll try to simulate multi-user scenario, and I'll show you what happens. Okay, let's register this, of course. I don't see green light. Maybe that's okay. Let me try.
Today is
Mhm.
the January 2024, 11:09 in the morning.
So that's one session. Let me mute it.
Okay, I got a busted ass here.
So I'll mute this one while still going in background. I'll make another session
Mhm.
on my desk phone.
Today is Thursday, 4th of January 2024, 11:09 in the morning. Welcome to Infernos.
No lawsuit won't cure.
Hey, I got a bug here. I don't see anyone kissing it.
As you see, it still runs. So if I unmute this
Bet
guy,
you didn't expect that one, Calculon. Hey, what the hell are you doing with my head? You guys realize you live in a sewer, right? Mila saved me, and yourself, I guess, and my banjo, and Fry. Yes.
but at the same time, you see the load is pretty much 100%. So if I make another session, it basically starts chopping and everything.
I said when we turned on the debate.
Let's face it,
But at the same time, you see the GPU is does not show like huge load, and I believe this is like fundamentally how those networks are built. In order to get actual good performance out of it, you need by which I mean like being able to do a lot of channels. You need to do batch inference. So instead of where's my diagram? Okay, so I don't need this anymore. This is like this. So this does not really work. Well, it works, but does not scale. So essentially, what we need, what I need to do, we need to I just duplicate this. Let me delete this. Duplicate this. So basically, this needs to be. Let's see. Group. Those guys should be grouped together. So essentially, you need to run each model in like separate thread, but only one copy of it. So you don't create multiple inference sessions for multiple clients. You basically have just one session.
And you're using the same session with for multiple calls at the same time, right?
Yeah, yes. Essentially, you run your model in one thread, and then you either, in this case, demultiplex because it's out. But if you have another direction, then you multiplex and put it like into like bigger batch. So you basically stack all your sessions as one big batch. So let's say you have 10 sessions or 20 sessions or 100 sessions. You aggregate them all in one batch and send it to the inference. And then after you get the result, you basically just get out like individuals data from that result and demultiplex it and send to actual user on each session. And this is essentially what I'm going to look at next as a project. Yeah, so that's the idea, and yeah, so this is like a little bit more in details. As I said, we need each of those will run only one, and we'll have multiple clients hooking to the same model. Yeah. So that's kind of high level overview. I don't know. You probably have some questions at this point.
Yeah, so many actually. So yeah, so one question that comes to my mind. So I noticed like whoever is watching this, I guess they would wonder like right now, with text to speech in specific, I see many businesses are utilizing, the popular text to speech services, say from Amazon or whichever, or Google, for TTS. So what would be the use case that, or what would differentiate using this versus using one of these cloud text-to-speech providers, right? And how does AI play into the mix of this, versus again utilizing one of these hyperscalers APIs for text-to-speech? That's
Well,
my number one
yeah,
question.
I think it's the same. The answer would be the same as Swipe, with people still using like their own phone systems when we have like Twilio and stuff. So
Right.
like, while there is like some of the use cases where like using fully like cloud-based black box provider would be fine, like for whatever reason. But there will be, I'm pretty sure there will be a lot of use cases where it's just not feasible for various reasons. So we already discussed it on, I think, on LinkedIn. So there is the privacy, there is this latency. It also, when you're using your own, you have very good control of how it works, what the quality of service is, even like, uptime is might be even better, because if something like in cloud goes down, you pretty much have no control of when it's getting fixed. It might be down for a few minutes, it might be down for a few days. You basically
Right.
don't, you have no control. And when your
Right.
business depends on it, it will be, for some people, it will be quite a big advantage, because
Sure.
obviously if you run call center, for example, and you depend on those services to do its work, you cannot afford it to be down even for like an hour, let alone like a day, right? And you can only guarantee this if you own the infrastructure, right? So then you can properly back up it, you can have like standby or whatever already there, and you have stuff on call which can go and flip some switches if needed or whatever, like fix
Yeah.
stuff. So yeah, I think that's the answers to that. And also it gives you a little bit, if you're building, right now we're looking at like isolated use case, like text to speech. But what I see, people will be building more like all-in-one solutions. There is also a lot of use cases. For example, let's say you're trying to build some kind of automatic self-serve kiosk where people can come and speak to it. It just makes no sense to send it to the cloud, right? Right now it does, because it's very difficult, as I just demonstrated, to just run it out of the box with a good performance. So some people these days might not have an option really, but to
Yeah.
go with the cloud. But once those technologies get more advanced and be able to pretty much run 100 or whatever 1,000 sessions on off-the-shelf PC. Then it will be pretty much very different game, and also like the cost of getting it up and running will be much lower. So you won't need to like have somebody like expert. It's like if you look at analogies with voice over IP, until like we had all those open source projects, a lot of people had to buy like commercial solutions, even for simple tasks. But these days, if you build just need like little AVR, you just put like free switch or asterisk, and
Right.
yeah, you have like bunch of you don't need to be expert in the field to get it up and running,
Yeah.
right? You can like find it on internet, or even like ask ChatGPT to help you, and it will give you like all configuration, everything you need.
Right.
So yeah, I see a lot of use cases for this.
What comes to my mind for the audience is like, so when you're doing things in non-English language, right? So once you start scaling globally, so whether AWS, text to speech, or Google, whichever, these are very generic and general text to speech services. Now, when it comes to, for example, in Arabic language, you have so many different dialects and accents, and pretty much these solutions won't really work out of the box. And here comes where, from what when you're running your box that comes with this AI model that's doing text to speech, where you can start now having the opportunity to fine tune it to your to according to the dialects and the accents that you care about the most, where you're serving. And now text to speech becomes very powerful, and having that level of control, knowing that, look, the hardware, the software, the underlying foundation is just works out of the box, and it's given by a vendor that would just give you all the initial, give you a head start on all this, and where you can just focus on your use case. I think this is a very powerful and is well needed. I've seen it as a problem in many different countries, where there are these amazing technologies, but they're not really applicable in everyday life in several parts of the world. So yeah, I think in addition to what you said, Max, I think there is that power of fine tuning that model to serve your specific purpose. And again, as you demonstrated, it's not like right now it's kind of complex, and what we're trying to achieve at Fuser AI is to simplify that underlying hardware, software foundation, the frameworks, and getting everything running correctly initially, so you can focus on your use case. This is something that plays a big role in it. I think also, like, what could be really interesting is, from there's a rise in this like kind of telemarketing or sales, two-way sales calls, that's like text to speech, and then you have speech to text with natural language understanding, where you can actually do a really high quality text to speech, very natural sounding. And if someone really cares, then you can connect them to an agent after like a little bit. But like, you can take a lot of the sales activity, like you can scale that to like thousands of calls, and once you really get the people who are interested, after getting all the heavy lifting out of the call, then you can route them to a human agent to kind of like do a hybrid model. And at some point, you can, once you have figured out your the whole flow of that specific business, you can actually fully automate your whole sales cycle with text to speech and speech to text. And then again, to get that right, I think it cannot be done without fine tuning your model. It needs to be fine tuned to your specific business and to your specific use case.
Yeah.
Mhm.
Exactly. And then again, right now, like if you try to do like cloud based, you will probably have to mix and match different providers. So not only you have disadvantages of extra latency latencycycycycy and not having control. If you build a complex application which uses several of those together, it's for like if you want to get the best quality, you might want to use like 11 labs text to speech and chat GPT from OpenAI and stuff. So it's getting quite quite complicated, and so it increases chances that something will break. And also, as I said, even like not having control is also very important because you don't know what they change. Like recently, like I think it was like months ago, people started complaining that ChatGPT like essentially became a little bit more lazy or whatever. So it would try
Yeah.
to kind of not not to go too deep into the uh, to the explanation. So who knows? Maybe they tuned up
Right.
some parameters to save tokens, or because tokens
Mhm.
cost money. So for them, it's a cost. So if they can tweak something to use like twice less tokens and still do like okay, then and then and then there is also a lot of interesting concepts that at some point I hope we'll get to explore. So, for example, if you run your own infrastructure, you can have kind of some long-term storage for each. So you know who the user is. You can save the context. So lot of intelligence. Those models kind of uh, provide. It depends on the context. So like if you go to like ChatGPT, I'll just give you some example here. Let me just share my screen. So yeah, so basically all those are actually contexts here, right? So and a lot of usefulness of ChatGPT comes from the fact that you can, just go back to whatever discussion you have and kind of go from there. Maybe you have some additional question, or maybe you want to explore deeper. And so all those sessions are just the context saved somewhere on the OpenAI end, and lot of those models that people will run in the future will have something like that, right? So if you're a customer of whatever business and you interact with their support, they will probably, and they have like built some AI agent. At some point, they will try to save this context, so they can tailor more answers more to you, and once they know it's you who is calling. So yeah, I kind of think that's also will become quite important to have some kind of permanent storage for those contexts and being able to access them as needed
Absolutely.
for various reasons. And all comes obviously with like privacy and security, because you don't want like like credit, even like if you look at like PCI compliance, right? It's probably not, you're not allowed to kind of offload some of those stuff to
True.
the
Yeah.
cloud. So you don't want your ChatGPT to store like client credit cards or something. So
Absolutely. Yeah.
you'll have to have for at least for some use cases to have this local storage for those persistent contexts as well. Yeah.
Sure. Yeah. So can we can summarize it in, I guess that, well, highly customizable for your specific use case, um, much lower latency than being on the cloud, more cost effective, because as we all know, whether with Twilio, whether with AWS, you're paying a premium as you scale. And initially it
Nothing is
starts,
free in life. Nothing is free.
yeah, but like you're
As they
paying,
say,
you're not
cloud
paying.
is just serverless, or cloud is just you running on somebody else's server, right? So somebody is
Yeah.
making money out of that. So
Mhm.
yep.
Right. And the actual margins are like, even if you're renting out a server or servers from which, from a data center, it's still way less margin that they're making versus like one of the brand names, that the popular brand names out there that are doing these. This is the reality of things. I'm not saying, I mean, we all appreciate lots of the, great technologies that some of these hyperscalers are providing, no doubt about that, but it's
No,
just
no,
that,
they're quite
yeah,
useful, right?
yeah. Yeah, but I've seen, I mean, like, whether like with, I think the cloud is great for, like, certain use cases, not every use case. There are, as you mentioned, like when, and then, comes privacy, where, you know there are some legal compliance that require you to have certain, what, like, if you want to make AI useful and have the context about me as a customer at this like health insurance company, you cannot have my data, being out there. It needs to be in many countries locally, and that company is responsible for my data and all that. So yeah, we can say privacy, cost, highly customizable, and the ability to, well, maybe the downside here is that maybe scaling it up would not be as quick as doing it in the cloud, right? So you would, yeah, you have that's the
Well, these
price you have
days,
to
yes,
pay.
yes, it's true. It's true in 2024, right? But as a good analogy to think about the AI and related technologies these days, it's like tube computing at this point. Like,
Mhm.
even if it's very powerful and stuff, but from the point of view of the end user, it's like that, right? You first you need to get like hardware, decent hardware that can run at least some workloads. You need to invest quite a lot of money. So it's basically not a lot of businesses can afford it. And and
Yeah.
so and so basically we're in that era, right? Where it only like 3 or 5 or whatever, like 10 businesses in the world can actually afford to have it in house. But as the technology develops, it will definitely get more democratized, and so lot of more use cases will become possible on just local running locally, and also it will not at some point it will become easier, so you won't need expert in AI technology to deploy those solutions. So somebody will with just generic knowledge of uh, of technology will be able to deploy it and get it up and running at a good performance. So yeah, give
Right.
it a few years. I think the
Mhm.
landscape will change quite drastically.
I
Um,
agree. I think, like, if you see, if people here in the audience see what's happening, unfolding on Twitter, or X, formerly Twitter, in real time, it's actually what Max has just described. It's actually, happening. There's lots of, activity going on to democratize, AI, and lots of companies are doing their local versions of AI, fine tuning their custom models for specific use cases. Actually, I'll share a little story, of how I, maybe me and Max got into this. So I started out saying, well, I wanted to do some use cases with AI, and I was like, all right, I'll just use OpenAI API, or let me try with that. I really don't want to reinvent the wheel. I really don't want to try to learn something, from scratch, like machine learning and AI. Yeah, but then I found out. So I was trying to do something simple, which is every week I see breaking news about these phishing, smishing attacks that's going on, in many countries, and there's a lot of victims about that. And I was like, how hard can it be to resolve, text classification problem? I mean, AI is pretty good at that, but let me test it out, right? So I started taking some of these real examples from either like in real time from X or from the past incidents, and I throw it at ChatGPT initially, and it understood it, it classified it as spam. It was like very quick, and there's great reasoning around it. It's very, very, very good, maybe better than a human being would detect that. And I was like, all right, so let me use that. Let me build a little something, a little API, a proxy that would just simply you give it the text from the SMS before you route it, and you just classify it, whether it's spam, whether it's legit or ham, right, or whether it's phishing, based on the reasoning or based on the message itself that's coming from ChatGPT, and give me that response, and I will then decide to not actually send that SMS to the MNO, or just park it. Like, you can still submit it and like generate revenue on it, but not actually send it to the MNO because it's phishing, right? And it worked, right? Like in a few hours, I had this like proof of concept, and it works. But the problem was that to get a good response, or to use the latest GPT-4, which was the greatest, of all in terms of text classification and reasoning, that thing took 30 seconds. Now, the problem with that is that in the real-time SMS world, you cannot wait 30 seconds to get a message delivered. That's a long, long, long time. You cannot, like, you will screw up the whole experience. But if you keep that whole experience under 1 second and do real-time lookup, then you're fine, right? So here comes me having to go into figuring out how to get this down to under 1 second. And I was left with no choice but to go the open source route and figure out this. So what I did, and I'll show a little demonstration of that, is first of all, I found this small machine learning library that is very efficient, very fast, does not require a lot of resources. It was developed by Facebook AI research team called FastText, and that thing is really really, really fast. You get like in probably 10 milliseconds you can get a response. So I did some fine tuning. I created a model that is very efficient, that uses powered by FastText, and I was able to get something that works. But it's not as accurate, right? It's really, really fast. It's like very, very fast. Does not require a lot of hardware resources. You can run it on your existing hardware, and you can scale it up to thousands of sessions or SMS per second, and you're fine. But the problem is, or not a problem, but the challenge here is, I wanted something that's more accurate. So the accuracy of FastText was not as good as something else. So I went with, the next one was BERT, BERT. I created, I find it, will basically train it with my data set. I have this really good high quality data set that's up to date, that's very recent, and I trained it using that data set. On BERT, that's where I hit the hardware problem. And that's when I realized, okay, well, with FastText, I was able to actually train this on my laptop locally and get it working. But then when I started using something more sophisticated, or had a different architecture but has much better accuracy in terms of classification, I hit the hardware problem. And that's where I was like, okay, I wish I have this little box that I can just use, and that's to try all these different things and do all these different play with all these different models. So with BERT, you have here, I'll share my screen and show you how this works.
Yeah, very interested.
Okay, here we go. And by the way, these are public on GitHub. You can use them, so and you can fine tune and train them yourself. So here you'll find like 3 folders. One is the API interface that deals with these 2 different models. And
what
then
about
you,
sorry to interrupt. What about dataset? Did you also post it somewhere?
I did not, because I used kind of like proprietary data set from our customer base, so I couldn't publish it. But whatever the final model, the binary file that's published is using that as the base, so it's trained already on that data set. But I'm working on that with the customer to see if we can get the okay to publish that.
I would be very interested, because this will generate quite a lot of interest.
Absolutely.
Anyway.
Yeah. So here you can see under the BERT after training with this simple file here, where we're passing it the data set, and then we are creating. So this is the data set file that we are using for the training, and then asking it to label it and all that. So after we load the data set, we are training it and outputting this file here, the BERT SMS spam phishing model file, saving it, and that's what we're using. That's the model that you'll see on GitHub that's published. After it trains, it outputs this file. And then we do have this tests file, basically has a stress test of like 500 messages that is being simulated, like SMS messages being simulated to the model. And you can use that to test on your own hardware, like how long is it taking to execute that. And here's a simple script if you prefer to initiate a test message using the command line, you can do it with that. There's some let me see here. There is some like examples of spam and regular communications that you can like pass into to test. But to keep it simple here, you can just use this API interface, like a web interface where you can just run locally, or use the online version of it. Okay, I'll use the.
Yeah, on that note, just a quick note, you should also probably explore Hugging Face spaces. It basically allows you Hugging Face. There's this site which holds a lot of open source models. It also built little like hosted demo interface where you can upload your demo code, and they give you like actual like UI that anyone in the world can just go in and
play with it.
Would be nice.
Yeah, absolutely. Yeah, I'll definitely take a look at that. So so basically here we can take this this message here. This is a sample message. You can just like test here. We'll pass it to BERT first, analyze it, and here what it does is it tells you like this is phishing probability is, and you can see here the time it takes to get the results. And here it tells you like the last training that was done on this model was on this day. And here is like you can also hit it through API, like you just copy this and paste it in your terminal. Does not require any authentication or anything right now. Then just hit it. Yeah, there we go. Anyways, so here, you get the same response. So you can hit it through API. You can check it out here, and also you can like give it a feed. So I created a little bit of feedback loop here. So if the results are not good, so it will like you can give it a feedback, and later on there's a cron job that retrains the model, and it kind of takes some of this feedback loop. After it's reviewed and stuff, it will like retrain according to that.
Oh yeah, that's actually I wanted to make this point. That's another reason why you want probably to run your model in house if you're building some kind of product, because you might get pretty good results with something pre-trained already, but as as you build it up, or as new types of phishing attacks come, or maybe you determine that lot of cases where it does not do the good job, you will definitely have to retrain. So you basically need to build kind of this loop where you not only do inference, but you also periodically retrain your model to include more use cases, and you can realistically, at least these days, do it only with like your own hosted like infrastructure, and that's how Comma actually operates. They build. I'll share some pictures with you, but they build a pretty big cluster in the office, so they have a full room full of basically computers with GPUs. It's like tons of and they collect each day people driving with their system, and they collect all sources of training data and periodically train their models and update them and stuff. So that's a very important.
Yeah, absolutely. I mean, you definitely need to have that, because also like with phishing and spam and all that, there's always new ideas that, or new techniques that are being used.
Yeah. It's like adverse. People who do this stuff, they eventually learn that they're not getting through this, so they figure out the ways to tweak. And it's actually not that difficult. I mean, it's even with machine learning models are not bulletproof. That classic example where people who can just tweak, take picture of panda, change like a few pixels, and give it to ResNet, and it says it's monkey or something else. Even though for you and me it looks like panda, so you don't see a monkey there. But and the same thing could be applied to like whatever systems you're building. The people who are stopped by this will try to find some ways to get through it with this little, with little, maybe adding some commas, or I don't know, just swapping the words. So.
Yeah, this kind of things, like AI is really good at it. Even the fast text model. So here, like you notice when you switch this to fast text, you will get much less processing time, like compared to BERT. So if we take the same message here, and again, these are not messages that the trained model have ever seen before, like in the training data set. They are completely not seen before. So you can see here, like if you switch to fast text and you hit that, look at the difference in the processing time. Now switch back to BERT, which is more accurate in some sophisticated or tricky messages, but it's slower. You get slower response time. Like here, you see that? Yeah. So what's interesting here, like let's combine what you did with, or what you're doing with what we're doing. So even this is like the concept of this was designed to give some AI help to SMS suppliers, sellers who do not have any protection in their network, to still have an option to use something like that. This actually could also be applied if you're doing real-time call speech to text, and you're passing it to this API, for example, and you're passing the conversation, like all of it or most of it, whether in real time or post the conversation is completed, you can actually get an understanding of whether, because the same sentiment analysis could apply, you could also train it on some, like if this whole phone conversation between the sales and the end user was kind of like sounded like scammy or fishy or something like that, you could actually have a label in your call center dashboard that could say, well, this call that was made, sounds a little bit of could be potentially a scam or a phishing attack. And there are some cases that are, you have these people, buying through cloud communication providers, buying services, and you like phone numbers, and they're dialing out from those services. They're dialing people and scamming them for money, for example. You could actually, how can you prevent that from happening? You only prevent it after the end user has been scammed and there's a lawsuit or something going on. And then they trace it back to the phone call, to the phone number, and all these crazy things happen after that. What if you actually onboard as a cloud communication provider, you're onboarding this new client and you're scanning their calls, for just a little label, a little flag saying, well, this client has so many calls that sound a little scammy or fishy or whatever, whatever you want to label it as, right? And then you could have an idea of like, this new onboarded customer, it does not seem to be all right, and they need to move. So you can apply these, two different things, hook them up together and come out with a more powerful solution to one of some real problems. So going from speech to text using AI to AI based on new data that's coming in, to tell you if this phone call had some potential fraud in it or something like that. So yeah, this is the idea. Now, our next step on this is to basically hook it up with our SMPP stack so that it becomes an option for the vendors or the suppliers to say, well, I want any traffic that comes to me to be filtered by this AI, and if it thinks it's phishing, what action to do. Submit the message, but build the message, but don't actually send it to the MNO, or reject the message, or or put it in review for a while or something like that. So yeah, these two models are open source. They're available on GitHub, where you can clone them and you can train them. You can use them as it is if you want, and you can collaborate and contribute to this project as well. So yeah,
That's great. Yeah, I'm definitely going to take a look at it and see if I can suggest or improve something. Cool.
Yeah, awesome. So what is? Maybe we can wrap up with a couple of questions to you, Max. And I'm always interested to hear your thoughts about these things. Where do you see, AI heading in the next few years from your point of view?
Well, from my point of view, we'll see more and more adoption of technology by all sorts of businesses who we usually don't think about as being very high tech. So I believe as future, if we go to the future again, going back to that analogy with early days of computing. At the initially, you have to be very technical, and you have to be very kind of really need to use computer for whatever you're doing. It should be like research lab or maybe big corporation or something to run financials. But as the future progresses, as technology progresses into the future, those things getting democratized eventually. And so I see this technology being pushed into less and less technical businesses, and down to, I don't know, like small restaurant or something. At some point, those people will be able to run it either locally or through some kind of hosting provider. And we'll see more and more product which will incorporate this. So obviously it's already in my phone these days in some form, but future is pretty much open. We'll see it in all sorts of smaller devices and bigger devices and whatnot. So we'll see a lot of that, and then most of the software probably on on the market in few years will use some of technology, some of that in it. My favorite example again, if you probably never heard of it, but Apple actually not Apple, AMD actually uses a little bit of neural network in their CPUs these days. So the branch predictor, the branch predictor, the like little module in the CPU which tries to predict where the control flow goes in the program, which is a very important task because the CPU needs to kind of prefetch the data and arrange like all the units. So it does it very quickly. It actually uses a little for a few years now. It uses little neural network. It's not a huge network. It's like I believe it's like 1,000 parameters or something. But it does very good job. I believe traditionally it was implemented just in the code, so the like Intel and other guys, ARM and all those, just hand coded this branch predictor logic. But at some point it became very difficult to understand what it does. So AMD took a little bit of the liberty, and it seems working very well. And so I see a lot of this technology is going to be integrated into existing software products and ecosystems. Down to whatever.
So the disruption from 0 to 10 AI versus blockchain. How do you? What do you think about that?
I would say it will probably more disruptive than blockchain, because blockchain is kind of interesting and it still holds a lot of promise, but it did not get much progress since original idea. Obviously they did get the capitalization, people started using, but I still cannot go and buy coffee with my Bitcoins. So it's like how many years? Like it's like 20 years now and counting. But on the other hand, with the AI, I'm pretty sure that it's already, when I buy in coffee, it's already some kind of that fraud detection systems. I believe I read some papers or presentations. They're already using some of the neural networks to do fraud detection. So at least those big players like Visa, MasterCard. Yeah.
Absolutely. Stripe. I know Stripe has been doing it for a while now, and it works really, really good. They were actually the first company that I've seen offer chargeback protection as a service. And it was powered by, it is still powered by machine learning and AI, and it works really, really well. We've had zero, like when we ran our marketplace for several years, and you get all these random companies signing up to buy, VoIP and SMS services and these things. And, you always, with PayPal, you had this issue with chargeback fraud. And with, once we switched to Stripe and enabled that service for an extra few percent transaction fee, we've had zero chargeback. They do all the heavy lifting of, deciding, and in case it happens, they will cover it. So, and it never happened after switching to that. So it's really, really useful and powerful. So I totally agree with your statement there. AI has a lot of real value that's being provided to almost in every business right now, and it's going to continue to get more amazing.
Yep, definitely. And obviously we don't know what kind of good models are going to be developed, and I'm pretty sure the amount of I'm just looking at the number of people who contribute on something like Hugging Face. It's amazing. And it's like there's like thousands and thousands people already publishing models and doing research, and a lot of papers come. So just amount of amount of kind of brain power that goes into this industry is just is incredible. And yes, it kind of should something should come out of it, definitely.
Sure. Great. And last question for you is, I know you're working at on hardware at Fuser AI, right? When can we expect the first prototype to be out, ready for
hopefully
showcase?
by the end of the month we'll get something that runs. I would not say it will run very fast, but parts already in shipping, so I'll start building it up as soon as it arrives, and so hopefully there is no setbacks recent, and I'll hope to get something by the end of the month, which we could at least demo. It probably won't look very funky, but that's not the point. We'll just get it running, and then we'll start improving it after that. Yeah.
Amazing. All right, Max, it was really fun playing around with these ideas with you, and hopefully a lot more things to come in the future. Thanks a lot for your time, and looking forward to the
Hey,
next
thanks,
session.
Ameed, for organizing, and yeah, definitely, it's good to have somebody who thinks along the same lines, and we kind of complement each other in many ways. So yeah, I'm very excited and look forward for this to grow.
Awesome. Have a great day, and see you next time.
You too, man. Have a good night. Have sleep.
Good night.